We did an interesting project like last year. One of our customers invited us to, they're using a multivariate data analysis tool called SIMCA, which is made by Sartorius Steedham, which used to be Umetrics. I think they bought Umetrics. So it's in the machine learning family, but it's principal component analysis, or PCA, and PLS, partial least squares. So they're a very linear, correlative kind of a thing. So if you have a process where if this goes up, this should go down, and it's a very linear correlation, these kinds of tools will do a great job at it. It's if this goes up by 5%, this increases by 50%, where it's more of an exponential, it doesn't find that stuff as well. But we were doing a training course with them, and the way that their people had always looked at the data was they were taking raw data in 1 minute, 5 minute, 10 minute, 15 minute chunks, right? And they were saying, hey, what changed? Or they were asked a specific question, which we'll get to here in a minute. But we took a little different tact. We said, okay, this was a Pi customer, so we took event frames. And we said, hey, let's take a look at time series data over each event, and let's look at when they make this product and they run it well, they don't have a lot of downtime, versus this other time where they run the same product and they have a lot of downtime. What's different between those? So we were kind of taking the data and putting it in different forms to ask different questions of the data.
Yep.
And most people don't think of it, and the data scientist doesn't even understand that. Right. The typical straight up data scientist doesn't necessarily understand that. They're great at the math behind the scenes, but they don't know that, hey, I have this product that I've run 15 times over the last year, 7 times I ran it great and 8 times I ran it horribly. They don't necessarily understand that, right? And they don't know to ask those questions. And I think what we've kind of found is our role is probably going to be in this. We're probably never going to be that true data scientist. I don't think we'll probably hire some people down the road that are, but like Ben and I's role and other people like Eric and some other people we're considering hiring, our role is going to be the translator between the two.
Because you understand the process, and the process is so important to understanding what the data is saying to improve.
No doubt. And then how to actually get the data and what form it needs to take on. Right? Because really what we did was feature engineering. Because we looked at that one particular product run, from a different perspective. That customer had never looked at their data that way, because they had never used Pi that way to look at it and contextualize it. And the thing is, I think pretty much any of the data sets, we didn't have to necessarily use Pi. We could have done some of that filtering with other things, right? But it was a very interesting kind of a play for us, because we wanted to see like how can all this be interrelated. So data quality is huge. How you do the feature engineering is huge, and you have to have a human involved. Until maybe 50 years from now, when you're still working and you're still working and I'm long since in the grave. No, I'm just kidding. Maybe we'll figure out how to do it all automatically. And it'll probably even happen in my lifetime. It'll get better. But I think